So welcome everyone. Today we'll be taking a journey through space and we'll talk about diamond, lightsabers, and levitation. Let's start our journey from the center of the Earth, which is at a very high pressure and high temperature. And what you find inside there is a crystal that we all love, diamonds. Diamonds are a fascinating and beautiful object that we have used in different areas. But what is a diamond? So diamond is a collection of carbon atoms where each atom is connected to 4 neighboring atoms, and then this structure is repeated throughout the diamond crystal. How to make diamonds in lab? To do that, we have to simulate these high temperature and high pressure conditions in the lab, which we do that using a cell called diamond anvil cell, where we squish things between 2 diamonds. The principle is that you work at a very small area close to the thickness of your hair, and then you squish the object between the 2 diamonds, and then you use lasers to heat your sample, which makes it a very hot material, and thus you get very tiny nano diamonds. Now, pure diamond is colorless, but how do diamonds get colors? Imagine a perfect crystal of atoms shown, and then you introduce a defect or an anomaly in it, and these defects are responsible for giving colors to everything that you see around yourself. So let's go back to the diamond again. Let's take the carbon structure. Let's take 1 nitrogen atom kicking out a carbon, and another carbon atom drops off, creating a vacancy. This is referred as the nitrogen vacancy, and it gives out green light when shown upon red light. Coming back to the surface of the Earth in our journey, you will see that how does internet work? How is a Zoom call possible? All this is happening because of a cable of connections called optical fiber cables, which uses light and lasers to transmit the data. Now, lasers are a very fascinating object appearing in different colors, different forms. But to connect the entire globe with such high-powered lasers comes high heat. And with high heat comes degradation. When we think about lasers in general, you would think that lasers are hot enough to burn through objects. They can burn through material. But in our lab, we make materials that can cool upon interacting with lasers. And these materials can be used to cool the fibers that we use. You all might remember this iconic scene from the Star Wars, which uses a lightsaber. What is a lightsaber? So a lightsaber has a battery and a crystal which lasers. Now, with that amount of lasing, you will have very high heat, and you can think about using the materials that you make in our lab, which can cool upon interacting with lasers, to coat on that lasing material, and it will help in lightsaber cooling, and it could then potentially help you to achieve a possible lightsaber. Now, imagine that a meteoroid comes and hits the Earth. That would be sad. We'll all die. So you could think about creating a Death Star-like object on Earth with really high-powered lasers to shoot these meteoroids in space. I do not want to upset any Star Trek fans out here. So let's look at this fascinating idea of tractor beams, which was introduced, where you could maneuver and control ships in deep space and objects in deep space using just light beams and lasers. In our lab, we have tried to create a miniature version of this tractor beam where we can use lasers, I should also say high-powered lasers, to control these particles in air, water, and vacuum. Depending on which laser is turned on, you can maneuver and control the particle and where it is going. You can join multiple particles together with each other, making a nanostructured assembly as shown in the video, where I'm using 1020 and 1040 nanometer lasers. Imagine you want to control ships and satellites in the space. You could do this with potentially using these trapping lasers. Now, that's what exactly the Breakthrough Starshot program is. The idea is that you will shoot a nanocraft into the space, and then it'll have some wings. You will have an array of high-powered lasers on Earth, which you can shoot, and it will push the object into deep space. This was the end of our journey that we took today. I thank you all for coming to this talk. I will like to thank all the collaborators that helped and are working very hard on accomplishing all these results, and the collaborators at the UW MEMC Center that have made all these sort of research possible. I would like to thank my group, the Pozowski Research Group, and the Material Science and Engineering Department, and I would welcome any questions towards the end of the talk.